Hello everyone, my name is Phoenix, and in this video we are going to solve our next CTF challenge, which is Pelusa. Let's see. So the title says you have just opened your eyes and you are in Mexico 1986. Help Diego set the score from 1 to 2 for a win and do whatever is necessary. Score from 1 to 2. Alright. Although I don't have some football knowledge, but it seems that we have a goal, one already present, and then we have to make a goal from 1 to 2 in order to win. All right, so we have an interface which is calling get ball position. The contract Pelusa has owner, which is the address like this. We have a function called pass the ball, which has two required conditions: is goal and shoot. All right, so what we first have to do is to successfully call pass the ball function and then to call shoot function. Our attack process will look like this. We have to somehow bypass these two required conditions. The first required condition, that is saying that message.sender.code.length should be equal to 0, which means that the contract code size should be equal to 0. This condition should be bypassed. For those of you who don't know, the size of the contract doesn't include the function invocations in the constructor, and so whatever the logic that you put in constructor will not be included into the contract code size. So in order to bypass this required statement, what you have to do is you have to create all the logic into the constructor itself. The second required condition, that is checking message.sender under modulo 10, should give out the following result as true. This means that we have to create an address that should be of our choice. For that, we need create two opcode to deploy our smart contracts. So there are two ways through which we can deploy smart contracts. One is create and the other is create to. The only difference between two opcodes is that create to can determine the address that the contract is going to be deployed at, and create cannot. So what we'll do is we'll brute force that in such a way that we'll get the desired contract at the address which bypass this required condition. Then in order to create this variable or change this variable from 1 to 2, we can use this delegate call, which will essentially give us the ownership of the contract so that we could access this immutable variables, since you know that delegate call works in the context of the sender, which means that the logic will be given to you in your state machine. So you can easily change this immutable variable to 2, and I think you will be able to pass the test. Let's see the solution. Here is an explainer.txt file that will essentially describe you in detail of whatever I've said. The exploit in the contract looks like this. So we'll first create a smart contract called Pelusa exploit. In this, we will call all of our logic into the constructor itself, which will be pass of the ball, and to call this owner like this. And the hand of God function, I guess, will increase this slot to 1 point and then return this value. Our main contract test file will look like this. First, we have to brute force the deterministic address, which can be done by this. We'll start a prank as an attacker, and then for I 0 to 1000, we'll deploy the Pelusa exploit with the given salt. As soon as this condition gets executed in the true function, then the for loop will be break. Then in the text exploit, what we can do is we will create a new instance of the smart contract. We'll act like an attacker, then we'll deploy the new Pelusa exploit to the salt that we have actually found. And if all of this has been successfully created, I think we will be able to assert that our goal will be changed from 1 to 2. That's the end of this solution. I hope you guys will replicate that into your local environment. Thank you for watching this and stay tuned for our next videos.